Hello everyone. Today I would like to introduce our work Asteroids, exploring swarms of mini-telepresence robots for physical skill demonstrations. This is a joint effort with my wonderful collaborators Mauricio Sousa, Li, Jessie, Chen, and my amazing advisors Ravin, Balakrishnan, and Tovi Grossman. Many important problems we face today, such as environment protection, requires creative solutions from people around the world. And many of these people live in remote areas with limited resources. An example is Fion Ferrora, a high school student who prototyped and built research instruments himself to remove plastic particles from water. To open up the opportunity for more people like Fion to learn the necessary physical skills for their innovations, remote communication technologies should facilitate the learning of physical skills, such as electronics prototyping. Remote physical skill instruction today typically involve an expert instructor demonstrating tools and processes through either live or recorded videos. In this work, we focus on demonstrations through live video streams. When live streaming their demonstrations, instructors often need to set up one or more fixed cameras. However, as you can see in this recorded live stream, fixed cameras do not always provide the most informative views. More importantly, fixed camera setups do not allow audience to actively explore the demonstration for their individual learning goals. For example, while this camera provides an excellent close-up shot, it cannot be reconfigured to show the machine used by the instructor, which may be of interest to some learners. The other challenge faced by today's physical skill demonstrators and instructors in many other domains is lacking awareness of their audience. What are the students paying attention to? What are interesting and not interesting to them right now? As Jiannan and colleagues pointed out in a paper published at last year's SIGCHI, instructors feel that they are talking into a void. In the context of physical skill demonstration, instructors may miss the opportunity to adjust their live tutorials in response to audience needs. Our idea is that the mobility and physicality of robotic embodiments can support audience agency and instructor awareness in physical skill demonstrations. Specifically, we propose Asteroids, an approach of using a swarm of mini-telepresence robots at the workbench scale as audience surrogates. Audience can observe demonstration activities from a robot they inhabit and find an angle they prefer by adjusting the robot's position and orientation. In the audience interface, users can see the camera live stream of the robot they currently inhabit, a preview for what another robot sees, a map showing the entire workbench and robot statuses, and direction buttons for moving the robot they currently inhabit. Audience can freely explore other areas in the demonstration workspace for individual learning goals. They can click on the map, and the robot will automatically navigate to the target position. Finally, audience can switch between different robots to get a new perspective immediately. They can do so simply by clicking on the icon of another robot on the map, and it will be automatically transferred to the new robot. While trying to support audience agency, we also recognize demonstrators' control of the tutorial flow. For example, what should be introduced first? What everyone should pay attention to right now? These can be crucial for effective explanation and instruction. Therefore, in Asteroids, we incorporate a set of tangible interactions for demonstrators' control of the flow. Demonstrators can reposition robots simply by grabbing and moving them using the holes on the shell. They can pick up a red command token and place it on top of a robot to make it stationary. Audience can choose to observe through the robot pinned in place or drive their own robots. Demonstrators can also place an orange token on a robot to grab the attention of all audience members. Here, we see the example of a guided tour through first the 3D printing area, and then the area for assembling individual parts, and finally, the area for soldering. Alternatively, Demonstrator can place a green token to highlight a region of interest. Our robots will turn to look at the marked region. Finally, demonstrators can manipulate pairs of zone tokens to define and resize work zones. Robots will automatically avoid work zones to reduce interference with the current demonstration. For the implementation of Asteroids, we use commodity webcams and fiducial markers to track robots and tangible tokens. A central server analyzes the webcam streams and sends control commands to robots. Audience connects through a custom WebRTC application. We 3D print the shell of the robot with holes on the surface for easy grabbing and a dent on the top for placing tokens. We insert an iPod Touch into the shell as a camera and the network device. Finally, we attach the shell to a motorized robot base. We conducted an exploratory online user study using an architectural scale model building task. The study involved in total 12 remote audience participants watching an expert demonstrator showing them how to build an architectural model. The learners attended the demonstration in a group of 4 through Asteroids robots. The demonstrator largely followed the script, but with some ad hoc adjustments for participants' needs. We collected qualitative and quantitative data from audience participants. Participants reported that Asteroids recreated an engaging experience of being in a workshop together with the peers and the instructor. They reported that the demonstrator paid attention to their physical embodiments, and this contributed to their sense of presence. The ability to move around to see different points of interest also adds to the sense of presence and helps them to obtain a clear understanding of the demonstrated procedure. And lastly, participants find the interface easy to use and the features useful. In summary, we propose Asteroids, an approach of using a swarm of mini-telepresence robots as audience surrogates. Asteroids leverage robot mobility and physicality to support audience agency and instructor awareness. Our interaction design further allows for instructors' tangible control of the demonstration flow. Our user study with remote audience participants found Asteroids benefited their engagement, sense of presence, and understanding. In our future work, we would like to explore the user experience on the demonstrator side and scale Asteroids up for more learners, more robots, and multiple workbenches. With that, I would like to conclude my presentation and welcome any questions. Thank you very much for your time.